Yes, thank you for the kind introduction, Julie. And thank you for being here to talk about the presentation. Or I was asked to talk about some technical status where we are today with EVA films in lamination processes. And that's what I would like to talk about. You can see here on the first page that this is a work of our team at Folienwerk Wolfen. So you can see the co-authors here on the slide. Okay, overview. After a short company introduction, I will give a short motivation, and then we will talk about the current status of the use of EVA laminating film in different lamination processes. Folienwerk Wolfen is a company located in Thalheim. I think some of you know that there is a company called Guardian nearby, or a factory of the company Guardian nearby. Folienwerk is a family-owned company. We are around about 160 employees in the company, and we are running 8 extrusion lines for different products. I will show you in a second. Yeah, Julia already said that we have an in-house R&D department, and due to our product mix, we are relatively good in traceability of materials. Okay, our products, you can see here some pictures. We are producing for more than 25 years now products for packaging, transparent polyester films for folded boxes, for instance, for blisters and so on. We are producing films for medical applications if needed. Then we're producing films that all of you have with you, I'm quite sure, because we're producing the films for passports, ID cards, driver licenses, and credit cards. And at least one of these should be in your pocket, I'm quite sure. And the last point here that you can see, we are also on the market for security and safety products. One of these products is the one I would like to talk about. Our product mix is, we are producing a lot of materials in the polyester business, and we are producing in the field of safety films based off EVA or materials as a combination. We can produce EVA film, and we can also produce so-called modified polyester. I will show you at the end of the presentation an example of this. Okay. Yes, of course, what's unique for us, we are producing multi-layer solutions. This means each of our films consists of several layers. This means we can make different mixtures of materials and so on. We are able to produce films with up to 9 layers in one film, and of course, mainly customized. Okay, let me come to a short motivation. I'm quite sure you know about this status of polymeric laminating films in the business at the moment. Most common for the production of laminated safety glass are the 2 processes you can see here. Right, the nip-roll autoclave process is well known, and there's also the vacuum technology available on the market. As we all know, PVB, of course, is a standard material if we talk about lamination in nip-roll and autoclave. Of course, ionomer, for instance, and other materials are also available, but not so much at the moment. And so far, as some of you are aware of, there is low experience with EVA in autoclave processes. If you look at vacuum technology, we have a different view, a different picture at the moment. PVB and ionomer films are not used quite often in these processes, but EVA is, let's say, a standard in the technology. I will show you in a second and some examples why this is. I will go through now, and then I will start my presentation, or this part of the presentation, with vacuum processes. The vacuum process, you can see some examples of machinery here. Is a process where you apply vacuum. We have seen this already also in the presentation before. Typically, this process is used for small size laminates or even specialties. Typical sizes we can see in this field are in the range of 2 by 4 meter. And as we see, or you can see on some examples, we have some special materials, special structures like switchable films or smart glasses. And the big success of EVA in this field is in the solar application, as most of you know already. You can see here 3 examples while laminating kiln. You have on the right side you see a material or a machine, a vacuum oven in a container, and you see here a machinery from solar industry, highly automated, high output, sorry, on a state of the art. Some specialties, an example is shown here when we make, where we see EVA in architecture or in building industry today, is for instance when we want to insert some special materials. Here you can see a switchable LC film. You see the 2 pictures, right? In one sentence, in one sample, you see the door is, the film is switched off, therefore you have an opaque structure. If you switch to the second state, then you can see, you can look through. The window or door or wall or whatever is clear. And so this gives you the possibility for privacy or other effects if you want. Challenge here, as you can see, such LC film is quite sensitive to temperature. This gives you some work to work on if you want to laminate it. Another example, what we see on the market is shown here. With vacuum technology, or vacuum technology is used if you want to prepare some laminates with special inserts. As an example, you can see here mesh, metal mesh, or other material inserted into laminate. And if you do this, of course you want to make it in a way that it is free of any kind of bubbles, and of course that you do not achieve any kind of twisting, warping, or other effects that you don't want to see. For this, of course, you need the right material, and I can show you in the next second why EVA is so successful in this area. On this diagram you can see the viscosity of the material at the temperature where the films are molten. We have done here a measurement of melt viscosity of EVA, PVB and ionomer at a temperature of 85 degrees C by means of a rheometer. If you do so, you see that there is a strong difference between the 3 materials, and this allows you that the film flows quite easily into every hole, into all structures that you have inside the laminate. If we go to our customers, then we see from time to time some things that have to be checked and have to be discussed with our customers. You can see here, of course, an insert, right, that you see, and you see here that it should be transparent and, of course, without any kind of bubbles. And if you look at this, then you have to talk to your customer what's the problem there, if it's not enough film or if there's a wrong process and so on, how to reduce or eliminate, of course, the bubbles. On the right side, you see another example. I hope you can see it. On the right side, you see that inside the oven, in this case, there was an in and out flow of the air, and they measured the temperature at the in and out flow, and they measured 85 degrees C. They said everything is fine. And then we installed temperature sensors on this machinery, finding out that the temperatures are, yes, in a range of 40 to, let's say, 75 degrees C, but not there where we need the temperature at the level as we thought. And this needs to be discussed, of course, and this needs to be find out and eliminated and improved with your customers. Okay, coming from vacuum technology and the next step to autoclave technology. If you look into this, of course, I think you have seen this picture a few minutes before from the colleagues. Autoclave technology, or Nipro and autoclave technology, is used, of course. Yeah, we have seen yesterday from the initial presentations all over the planet in big volume, right? Mainly for, yes, mass production, big sizes if needed. Typically size 3.2 by 6 meter. If you go along here, then you can see that today we talk about 3.5 by up to 20 meter. If we want, this is also possible. And yes, this process is the standard process for safety glasses. It's always a combination of the Nipro process, as shown here, and the autoclave. As I said already, this process is used for big-sized materials, for facade, balustrades, safety glasses for windows, and so on. In this process, of course, the main thing, we heard it already, the main topic is to make the laminate free of any bubbles. Here you see an example, what we have seen at one of the trials, or at one customer, how the glasses or the laminates looked like after the Nipro process. You can see a lot of failures or structures inside. I will not say failures because after autoclave we have seen that we can heal this. But this is what the outcome can be from the Nipro process, but then you need to get the right process. Another observations that we know from this process which have to be considered, you can see here on the left side, this is from the cut from the film during the preparation, and depending on how the autoclave was run, it looks like gives different structures and may stick on inside and so on. This is also not wanted. Another observation we have seen, and a failure that we have seen, happens if you run the autoclave with the standard program as you know it from PVB. EVA is a little bit sensitive, therefore we need a changed process, and therefore if you want to eliminate this kind of bubble lines that you can see on one edge or at the end of the glass. Another thing that can be observed from time to time are shown here. We can see here, this is in front of the Nipro process in one line, that we had some problems on one side, right? This was due to the set of the nip rollers, of the calendar rolls in the machine. Another failure seen on the right side, as you have here, is when the pressure of the nip roller was not sensitive enough for the product that we wanted to produce. Both things have to be investigated, and regarding troubleshooting needs to be eliminated, of course. If you talk about autoclave and autoclave products, then of course we know that a lot of products are used in architecture, for balustrades, for open edge products, and so on. If you talk about EVA for this kind of products, then we see here another advantage of EVA laminating film for applications where we want to have open edge, or where we want to insert sensitive, moisture-sensitive materials, and so on. You can see here moisture absorption of different materials, EVA, PVB, and ionomer. Done following the ISO 62 regulation, and you see that there's a significant difference between these materials. This offers you advantage if we talk about the lamination, and if you want to avoid such pictures like you can see on the right side. Okay, another product that can be done, or laminate kind of product that can be done in autoclave, is when we combine EVA and a kind of polyester. Folienwerk Wolfen produces polyester for a long time, and in our house we have also one product that can be used in lamination with EVA. We call it Mpe Modified Polyester. The way that we do is shown here, right? Of course, the polyester is as an insert between the EVA laminating films, and so we can produce glass laminates with special properties. It can withstand high thermal loads or even wind loads. We have done hurricane tests with a product like this. We can print on this film if you want to make decorative things, and so on. As an example, I will show you some results from balustrade testing that we have done early this year. Please go on with the video. Okay, thanks. Yeah, here we have done impact testing. Some of you know that balustrades are proven by deflection and impact testing with a pendulum. We have used 8mm toughened glass, EVGuard and Mpe film between. You can see the result of this. Here it allows you, of course the glass is breaking, and it allows you to keep it standing up. And then we changed the Mpe, the thickness of the material inside. It can absorb more energy, and the result can be shown here. This test was done in cooperation with Q-Railing earlier this year, as I said. Okay, I think that's more or less all for my presentation today. This gives us a chance to talk about it later again. I would like to summarize this presentation of today. I was talking about the current status of laminating films in nip-roll, autoclave technology, and vacuum technology. As you have seen, of course, or you have seen, there are different laminating films in use. EVA film, of course, is one of it that can be used in both worlds in the meantime. For each product, whatever you do, you need to find the right material, you need to find the right material combination, and of course the optimized product combination to get your best results. And it's also needed to get the advice from your technical supporters. Then I can finish my presentation. I thank you for your kind attention, and I'm here for your questions.
Thank you. Thank you very much. Are there any questions? Yep.
Hello, thank you for your presentation. I had a question concerning the, you mentioned the jumbo size with the EVA, and my question was about the cutting of this product. How does it compare to cut a laminated glass made of
to cut the laminated glass afterwards? Yes, of course. You can use all the processes that you know from industry. Of course, we do it. Our customers are doing the same, producing jumbos or bigger sizes, and then they cut out what they want. We do the same if we need our samples for R&D work and so on. Yes, we've done water jet. We have done normal cutting, as you.
So using the same cutting table as PVB?
Yes.
Okay, thank you.
Any other questions? No?
Yep.
What will be the future in size, widths? What is possible?
Okay, the future, what is possible? We have seen, the point is not the length, the point is the width, right? You are quite often at GPD, I know. Therefore, if you remember a few years ago, we had some talks here from other people, like Glass Labor, for instance. They were able to make multiple widths of EVA film or other films, not only EVA, right, to change the width. I don't believe that we, with all the handling, that we go over 3.5 or whatever meter, because we hear from the industry that this is technically not what they currently do and need, and also in future will not do. Therefore, we can do. We can at the moment we can produce 2.3 meter in width. We will change it soon to 2.4. This fits to most sizes of our customers that we need. And if they need wider, then of course we have some possibilities to do so.
Anything else? All right. If not, thank you very much, Steffen.
Hi there. Did you like what you just saw? If you did, why don't you like the video, drop us a comment below, and share the video as well, since GPD is all about sharing. And to receive more videos in future, subscribe to this channel and don't forget to click the bell icon. Ciao!